And 2 says the points M and N are the ends of a diameter of a circle, and it says determine the equation of the circle C. So the points M and N are diameters of a circle, and they want us to determine the equation of C. I love when we see a picture of what's going on. So I'm just going to draw a circle. I'm going to draw it over here, and these are two endpoints of the circle, the diameter. So maybe M is 3, 2. Maybe 3, 2 is somewhere, let me see. X is 3, Y is 2. Let's say maybe here. This is the point M. And N is the point -1, 4. Okay, since I want to be accurate, let me make it more accurate. So M is somewhere like right here. This would be M, and this would be N. All right. So this is the diameter. All right. So to find the equation of a circle, we need the center. But the center is just the midpoint of these 2 points. Right. So let's call the midpoint C. C for center of the circle. All right. So to find the midpoint, in this case, the midpoint is going to be equal to x1 plus x2. So it's x1 of 3 plus x2, which is -1, divided by 2, comma, y1 plus y2, which is 2 plus 4, divided by 2. This will give us the center. All right, now 3 minus 1 over 2 is 1. And then 2 plus 4 is 6, 6 over 2 is 3. So the center of the circle is 1, 3. Nice and easy, the center of the circle is 1, 3. Now that we have the center of the circle is 1, 3. Now that we have the center of the circle to be 1, 3, we can go ahead and continue and find the radius. The radius is going to be the distance. You can look for NC or the distance CM. Because I like working with positive numbers, I'll find the distance CM. That's the length of the radius R. So the radius R is equal to the distance between C and M. The distance between C and M is y2 x1 minus x2 squared. So it's going to be, C is from 1, so it's going to be 1 minus 3 squared plus, we're using the distance of the line formula, 1 minus 3 squared plus, difference in y values now, 3 minus 2, 3 minus 2 squared, and that will be equal to r squared. We don't even need to square root it, we just need to find what is r. So 1 minus 3, then you square it, that is 4, plus 3 minus 2, then you square it, this works out to be 5. So r squared is equal to 5. Now that r squared is equal to 5, the equation of the circle is x minus the center, so it's x minus 1 squared plus y minus 3 squared is equal to r squared, and r squared is equal to 5. That's the equation of the circle. Nice and very easy. Soft. All right, like when we get a diagram to see what is happening. Then it says find the equation of the tangent to the circle at the point -1, 6. Find the equation of the tangent to the circle at the point -1, 6. First, I just want to check that -1, 6 lie on the circle. Well, even though they're asking for the tangent at the point, find the equation of the tangent to the circle at the point minus 1, 6. I just want to point out that this is actually incorrect. Incorrect because this point P is not even on the circle. So this is what AdMath is doing. They're giving us wrong question right here. Minus 1, 6 is not a point on the circle. Minus 1, 6 is not a point on the circle. But let's just go ahead and do this question and find the equation of the tangent. But they're giving us wrong questions like this because this point is not on the circle. It cannot be on the circle. All right, and I don't like when they do that. All right, so let's say P is here, which we know it is not. All right, so you have some tangent. Let's just call it P, and we want the equation of the tangent. To find the equation of the tangent, we need to first find the normal at P, and the normal will pass through the point P and the center. All right, this will be the normal. So first we need to find the gradient of the normal. And the gradient of the normal is equal to the y value at P minus the y value at C. So it's y minus 3 over the x value at P minus 1 minus the x value at C. So that works out to be 6 minus 3, which is 3 over negative 2. So that's the gradient of the normal. If the gradient of the normal is 3 over negative 2, then the gradient of the tangent is 2 over 3. If the gradient of the tangent is 2 over 3, then we can proceed to find the equation of the normal. The equation of the normal is then y minus y1, y minus 6 is equal to the gradient of the tangent, 2 over 3 into x minus x1, which is x minus minus 1 or x plus 1. That's the equation of the tangent. You may proceed and you can go ahead and just put this in its standard form, but I won't because that's a waste of time. This will be the equation of the tangent. Nice and easy. Now, the vectors part of the question. It says the position vector of 2 points A and B relative to a fixed origin O are A hat and B hat respectively, where A hat, this symbol above it means A hat is a 1, 2, and B hat is minus 3, 5. Lies on AB such that PB is a quarter AB. And then they say find the coordinates of OP. All right, so this is just C-set maths question. We know what is vector PB. Vector PB, as we know it, is equal to vector of the last, which is OB, minus vector of the first. So this is OB minus OA. All right, that's vector PB, but it's also equal to a quarter vector AB. So it's equal to a quarter of vector AB is really OB minus OA. That's vector AB. All right. So pretty much we have this equation we're solving. Vector OB, and my apologies for writing OA here. This should be OP. It should be OP. So we have OB minus OP. And that's equal to a quarter OB minus a quarter OA. And all we're going to do is make OP the subject. So we have a quarter OB minus a quarter OA. Nice and easy, soft. So let's go ahead and make OP the subject. To make OP the subject, minus is here. So let's make OP the subject by bringing OP over here and bringing everything else over there. So what we're going to get is OB, and I'm going to bring over a quarter OB over here to get minus a quarter OB. Then I'm going to bring over the minus a quarter OA over here to get plus a quarter OA. And that's equal to vector OP. All right, so I bring over the OP over here to say that's equal to vector OP. So now that I have what vector OP is, I can just add them now because I know what OB is. OB is negative 3,5 minus a quarter of negative 3,5 plus a quarter OA, which is a quarter of 1, 2. And that will give me vector OP. All right. This will give me vector OP. But it said find the coordinates of OP, so I can't stop here, so I have to actually work it out. So let's simplify it. So, okay, let me see. Simplifying this, the x coordinate is just going to be minus 3, minus a quarter times minus 3 is plus 3/4. Then a quarter times 1 is plus a quarter. Then I have 5 right here. Now minus a quarter times 5 is minus 5/4. Then I have a quarter times 2. A quarter times 2 is a half. Nice and easy. So now we can continue. So now you have minus 3 plus 3/4 plus a quarter. Minus 3 plus 3/4 plus a quarter. That's negative 2. This is negative 2. Then you have 5 minus 5/4 plus a half. What are you getting? 5 minus 5/4 plus a half. I'm getting 4.25. I want to write 4.25 as 17/4. So it's minus 2, 17/4. All right. So that is vector OP. Nice and easy. All right. So if we wanted to actually just write it, and maybe you want to put it in numbers. I don't know, some persons like to see numbers. Instead, when I say numbers, I mean decimal numbers. So you can write it as 4.25. Depending on what flavor you are, you write it how you want. That's vector OP. Question 4. Question 4 says, the following diagram, not drawn to scale, shows the area of sectors AOB and DOC, and it says OB and OC are x and x plus 2 respectively. And it says if theta is 2 pi by 9, calculate the area shaded. All right. I really don't like this question because they don't even have a connecting part that is going to end up somehow making us find x. So I really don't like this question, but let's just do it anyways. The area shaded, AS for area shaded, it's equal to area of the sector, DOC minus the area of the sector AOB. Now area of a sector is equal to a half r squared theta. All right, so that's the area of sector, half r squared theta. So it's area of the sector is a half r squared, which is x plus 2 square theta, and they have this, and theta is of course 2 pi by 9. So it's a half r squared theta minus a half r squared theta. So it's minus a half. In this case, r is x. It's a half x squared 2 pi by 9. Now, maybe you want to simplify this. It's up to you. If you want to simplify it, you can notice that this 2 is going to cancel this 2. All right. And this 2 cancels this 2. So if you want to simplify it, you can get that it is equal to pi over 9 into x plus 2 all square minus x square. X plus 2 all square minus x square. Now you may want to simplify this if you want, right? You can simplify this if you want. You can identify that this is a difference of 2 square and then simplify it, or you can expand out the bracket and simplify it. Let's simplify it then. Due to shortage of space, I'll expand the bracket inside here. So it has to be x plus 2 all square, as you know it is. X plus 2 all square, we know that this is x squared plus 4x plus 4. But then the x squared over here going to cancel the x squared over here. And so you just going left back with pi by 4 times 4x plus 4. That's all we're going left back with. Nice and easy. Soft. So that's the area. And remember, area is in terms of centimeters squared. Nice. Now let's look at the next part, part B. Part B says, given that cos of 30 is root 3 over 2 and the sine of 45 is root 2 over 2, evaluate the cosine of 105 degrees. Now, they give us 30 and they give us 45, but they don't give us the important one, which is 60. You see what I'm saying? The one that I'm going to use is the cos of 60 plus 45. That's 105, don't it? I can rewrite the cos of 105 as cos 60 plus 45. Why would I need 30? I don't need 30. I need 60. Why didn't they give me what cos 60 is? Cos 105 is cos 60 plus 45. Now cos 60 plus 45, that's going to be equal to the cos of 60 times the cos of, let me write it in a new line. It probably won't fit right here. So cos 60 plus cos 45 is equal to the cos of 60 times the cos of 45. So it's equal to the cos of 60 times the cos of 45 minus the sine of 60 times the sine of 45. That's how you evaluate this question. So then what is cos 60? Cos 60 is a half, and cos 45 is root 2 over 2. So this is going to work out to be a half times root 2 over 2 minus the sine of 60 is root of 3 divided by 2, and then the sine of 45 is given right there. The sine of 45 is root 2 over 2. So working this out, it finally works out to be 1 times root 2 is root 2. So it works out to be root 2 minus, now root 3 times root 2 is root 6. So it works out to be root 2 minus root 2 minus root 6 over 2 times 2 is 4. So let's put over 4. So it's root 2 minus root 6 over 4. Joining them as one fraction. Nice and easy. Soft. All right. 5 marks to do that, to do nothing. Now it says now prove this identity that the sine of theta plus alpha over the cos of theta. Cos of theta cos alpha is the tan of theta plus the tan of alpha. Now I always like to start with my left-hand side. I love by saying LHS, my left-hand side, which is the sine of theta plus alpha. And that is, of course, being divided by the cosine of theta times the cosine of alpha. So let's work out this easy question. The cosine of theta times the cosine of alpha. So first thing to do this question, we expand the numerator. So it is expand, now sine A plus B is equal to, the compound angle for this is sine A, sine theta, cos B, cos alpha, minus cos A, which is cos theta, sine B, which is sine alpha. And all of this is being divided by the cos of theta times the cos of alpha. Nice and easy. It's being divided by the cos of theta times the cosine of alpha. Now, when we get to this question now, all we need to do now is, okay, this is now equal to, we can do the division. So let's do the division. Now we can separate them. All right, as sine theta cos alpha, separating them as sine theta cos alpha over cos theta cos alpha. All I'm doing is separating it into two separate fractions. All right, just separating it into two separate fractions. So this part as one fraction minus this part as another fraction. Why is this minus? This should be plus. All right, sine of A plus B, this should be plus. This should be plus. Cosine of theta times the sine of alpha over cos theta cos alpha. Cos theta cos alpha. Now that we have this now, all you're required to do now is cancel. All right, now cos alpha cancels cos alpha here. Sine over cos theta is tan theta. So that is how they get the first tan theta. Look how that easy, man. Nice and easy. Then the cos theta over cos theta cancel. And sine alpha over cos alpha is tan alpha. So we get tan theta plus tan alpha, which is equivalent to our right-hand side. Nice and easy, soft. Nice. So see there, we're nice now, we're nice. Nice. I'll go around here, question 5. Now, when we get to question 5,